Awesome. And thank you for the organizers of the CV4ARVR workshop for the kind invitation. I mean, it's amazing to just see the lineup of speakers. And so I'm really happy to be sharing what we are doing at Streem. So at Streem, we are making the world expertise accessible to everyone through remote AR. And so during this talk, I will talk about how we do that, how we accomplish that mission, and how computer vision is a core part of the ways we make this possible. So a lot of people in this workshop will be familiar with augmented reality, especially solo AR and shared AR. So with solo AR, you have one device in a physical scene, and you are augmenting the video feed with some augmented content that is only visible on that device. And then when you think of shared AR, you have multiple devices in the same physical location, and you are then, both devices are seeing the same world and are seeing typically the same augmented content, with the requirement that they both have to be in the same physical space. And so when we think of remote AR, this is something very different. You have one device in one physical location, and then you have other devices that might be very far away from the initial device. And so those remote devices are seeing the augmented world. They can modify the augmented world, but this is all overlaid on top of the video feed from one device. And so we at Streem are using remote AR for a various type of customer experiences. And the next video is going to give you an idea of exactly what that looks like. So here you have, here you have a set of customer experiences where you have remote users who are professionals helping customers with things like home appraisal, things like fixing your washing machine, as well as making measurements for design. And so during this presentation, I'll be talking about some of these customer experiences and how computer vision is helping these users do this. Okay, so when we think of remote AR at Streem, we are really thinking of a set of experiences that is unlocked. And so the first one is discovery. And so this is beyond the idea of being able to put a chair in your environment and seeing how it fits before you buy it. When we think of discovery, we think of applications like being able to get a code for a painting job without the painter ever needing to step foot in your environment. And so you have someone, a painter who is remote, who is using Streem to look at your living room and who can make a code for the job without having to come into your space. And so we've seen that commercially, this has increased bookings and business by 30%. And then one other use case that we are seeing is design, especially when you think of kitchen designing. So you have designers that can be sitting somewhere in the US, whereas you have a kitchen in Europe, and you need someone to help you design it. And so you could have these designers sitting remotely, but having a view into your living space and helping you build a new design for your kitchen. We've also seen that this is really key in increasing business, and just opens a whole set of use cases for customers. And so one other use case that I'm very, very passionate about is nurturing, is engaging, where you could have self-help tutorials. So when you think of AR, for me, this is one of the best use cases where you could have self-help tutorials, augmented reality tutorials around your appliances to tell you how to troubleshoot, how to get started. And this can be done in a way that's contextual to what is in your environment. And so where we see kind of we see the power of remote AR is in these last two applications, the nurturing and the support applications, where you could have someone help you fix your home repair issues from somewhere across the continent. And so we've seen that not only this help customers fix issues, right the first time, or even before someone actually shows up at your place, they know what's wrong with your appliances, they know what material they have to come with, they have measurements, and they're well equipped to do it right the first time around. And you don't need multiple visits to, let's say, fix your garbage disposal, for instance. And so during this current crisis, this pandemic that we are all going through, this has never been more important. And so there was this feature in New York Times where they say that Streem could be the telemedicine for home repairs. And I think that that's very true. We've seen customers and contractors tell us that this has really made a big difference, because in some instances, no one has to come to your place to fix your appliances. Sometimes they can just walk you through what's wrong and help you fix it. And if they do need to show up, they only need to show up once. And so in a season where we want to limit our exposure to the virus, this has been very helpful. And so if you want to go deep into kind of what a remote AR platform looks like, we have on one end, we have a customer who is on site, typically in a home, in a house. And then on the other side, we have a professional, an expert, who is well equipped to fix whatever issue the customer has. Now, the expert is remote, and Streem is sitting between these two users to transfer things like video, 3D content, other type of metadata, like what kind of device it is, what is the model number, what is the serial number, and also just like examine this data and extract content that might be useful for the pro in fixing the issue at hand. And so in order to really support the users to the best of our ability, we need this to be available on a variety of platforms, AI Kit, iOS, on the web, as well as mobile web. And so this has had an impact into what our team, the research team at Streem, how we look at the solutions that will ultimately be deployed and what decisions we make early on during our investigation process. And so this means that, yes, we have some constraints, but also this gives us the opportunity to decide whether we want to, some solutions needs to be deployed on the device or on the cloud. Obviously, on the device, things are a bit cheaper because we can kind of leverage the existing GPU on devices. For those devices that do have GPU, we can be memory efficient, we can leverage user input and give really quick feedback. And on the cloud, we can start thinking of potentially more memory intensive solutions. We can start leveraging large AI models, and we can start looking at solutions that have high accuracy to the expense of like being resource intensive. And it's quite a nice setup where we kind of we can pick and choose where we want to deploy our solutions. Keeping in mind that sometimes because of privacy reasons, some solutions can only be deployed on the device. So this brings me into kind of the technical bit of my presentation, where I will be touching on some of the research problems that we are solving to support the experiences I've mentioned earlier. So our research team some of the problems that we are looking at can be split into 3 categories. You have spatial mapping, where you're trying to get a geometric understanding of the scene. This is really important for things like measurements. And then you have object recognition and just semantic understanding of the space, so that we know what objects are in there, what is relevant and what can be passed along to the pro to better support them. And finally, we have an AI component that you see coming up in spatial mapping or object recognition, but also AI is used for things like natural language processing, where we are trying to extract metadata like serial numbers and model numbers from the video data. So for the purpose of this talk, I will just focus on three problems we've looked at. The first one is real-time mesh texturing, where you have a mesh, but you cannot really take measurements on that mesh unless you have a clear depiction of the texture. And then we have 6D pose estimation for walkthroughs. So if you want to attach an AI tutorials around a washing machine, then we need to know exactly what is the position orientation of that washing machine to best overlay content on top of it or around it. And then a very important piece for enterprises is being able to extract metadata like serial numbers for auditing and reporting, and just for folks to be able to find the right pieces when something needs to be changed. So I'll start with metadata extraction. So this is quite challenging because various manufacturers have various standards for how they set up their identification labels. And so we have to not only deal with that, but also we have no control over which angle this data might be viewed from. So obviously, if you have very skewed angles, that creates distortion, which makes it harder for the algorithm to read the labels. And so the approach we took is kind of to leverage existing work around OCR and deep learning methods for text extraction. And once we are able to extract text from these labels, then we can simplify our problem to just identifying which text is relevant and which text is important. And so what we've done is build some classification models that are able to look at OCR output and be able to identify which ones are, for instance, serial numbers and which one are model numbers. And we can then pass that along to the professional for further processing. And so they can use this to, like I said, for auditing, reporting, finding the right materials for the issue at hand. Now, the next really important bit that we've been working on is 6D pose estimation. Now, as a regular attendee of CVPR, there is a ton of work around this subject, around 6D pose estimation. And we can all think of like a host of deep learning methods for doing this, whether it's regressing pose from images or identifying key points from which we can then get pose through a PNP solver, for instance. Now, we saw in practice that this didn't really work well for our use case because in some instances, like in a lot of instances, you get errors that are around 10 degrees, for instance. And so if for the purpose of overlaying AI tutorials on top of, in this instance, a washing machine, that degree of error is not acceptable. And so what we had to look at are more kind of region-based methods where you can start off from an initial position and refine that position based on the data in the image, or in this case in the video. And so this has some connections to the model fitting work that Jamie was talking about earlier this morning. Except that in this case, you don't have any depth data, you only have RGB images to work off. So in this case, you can see how after the fitting, you have a really nice 3D model aligned with the actual washing machine in the scene. And so we are using this type of algorithm to then create 3D content around this type of appliances. So I just wanted to mention that we extended Tajin AR work from 2017 on region-based model fitting, so that it will work best for the type of appliances we are seeing in our customer homes. And so this only works well if you have a good initial position. And so yes, we can use deep learning for that, but we had to generate data in order to train our model, because in a lot of instances, these appliances are in tight, cluttered spaces. And so we are currently experimenting with user experiences where users can kind of give us this initial data, in this case, key points on a washing machine that we can then use to for data collection, one, and two, that we can then use in a live scenario to produce a good post that would then be used for the walkthrough. And so this is how we are really leveraging user input to really help them with whatever issue they have at hand, but also to collect data so that later on we can automate the whole process. And so this has been a really cool project to work on, as we are seeing more and more data from different homes, from different scenarios and user scenes. Okay, next, I wanted to touch a bit on our real-time mesh texturing, because this is really this could be very specific to the type of customer experiences we want to support, where you have a pro who is remote and who wants to take measurements in the customer home. Now, if you only have a mesh, and there are various ways of getting this mesh through many frameworks out there, including our own. But a lot of the time, these meshes don't have textual data attached to it, not in real time anyway. You will have either no texture, or you have per vertex color, which is kind of blurry, and it's really hard to kind of make out edges, which makes measurements really hard. And so in this case, we have developed a solution for real-time mesh texturing, which really help customers and professionals take measurements in real time, because they have a clear depiction of what texture are behind the mesh. And so in this case, you can really make out the cupboards, and you can really pinpoint what are the edges, and where you need to tap, for instance, to measure something. And I will talk a bit about measurement in the next few slides. So this is a case where a professional was directing a customer to a stove, and in this case, you can see the professionals taking measurements of the stove. And you can see why texture is so important. This would be really hard to do if you had no texture, or if you only had like wash out colors, because you're averaging those colors over multiple frames, and you only have color information per vertex. And so this is one illustration of why this is so important to have texture information on top of these meshes. And so traditionally, people have done texturing after the meshing process, because this is really expensive. This is done after the meshing, and this takes anywhere from a couple of seconds to minutes, depending on how large the mesh is. And so I just wanted to kind of quickly go over the typical process, where first you have a viewpoint selection. You are assigning a camera view to each face on the mesh. And then you end up with these textual patches on your mesh. And what you can then do is do some color adjustment for each textual patch, so that you have a smooth texture everywhere. And so this is very expensive, because you're typically solving some you're basically minimizing some energy function across many camera views and many mesh faces. And then you have to kind of look at all of this information and figure out how to color adjust your textual patches.
Flora, just letting you know you have about 4 minutes left.
Awesome, thank you. And so this is what we do. We are able to, on the fly, we determine what frames needs to be used as texture on what faces, as well as, what are the texture coordinates for each of these vertices. Keep in mind that this mesh is dynamic and it's changing every frame. And so this was quite challenging in terms of, when do we decide that we want to apply a mesh, and what face is assigned to what view, and how do we kind of keep in memory past views that we've seen so that we can always kind of do, we can match some faces to like prior frames. And so although this is challenging, we have had some really amazing early results, and this has been very helpful for our customers. So in this example, you can see a texture scene and some measurements. You can also imagine that you have, you will get some artifacts from, lighting changes, things like drift. If there's drift in the camera tracking, then prior camera poses that you had might no longer be correct. And so you have these shift, these seams in the environment. And so we are currently working on ways of fixing this in real time so that we can provide, really high quality textual meshes to our professionals, experts. So just wanted to kind of end with what we feel is the next frontier for our work. And what we think spatial AI is all about. And it's really about video understanding not only the geometry of the scene or what is in it, but understanding what problems what is the issue in the customer home, what are the potential fixes that the professionals is suggesting, and be able to understand this at such a level that you can start training ML models who will be able to look at some scenes and automatically know what to suggest. If you are able to kind of open up your phone, have it look at your washing machine, at the situation that you have, and being able to kind of have immediate troubleshooting AI tutorials on how to start fixing it. I think that would be amazing. And so we are slowly working towards that kind of, those kind of experiences. And so this is, for us, this is what spatial AI means, is solving real problems in real people's homes that desperately need this type of solutions. So just a plug to say that you are hiring. So some of these problems are really challenging, and we are building a big research team. So if any of this is interesting to you, definitely reach out. And I will end by thanking my collaborator, my colleagues, Ghislaine and Pavan, who have all worked on the research problems I touched on today. And I would like to thank all of you for your attention. Thank you.